Welcome to episode 89 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today's episode is all about Nvidia, from graphics to AI gold.
That's right. Nvidia started as a graphics company, but has become a powerhouse in AI, reshaping industries with its chips and compute power. It's a fascinating journey.
Let's start with some basics. Nvidia is best known for its GPUs, which stands for Graphics Processing Units. Originally, these chips were designed to accelerate rendering images, especially for video games.
And those GPUs became essential because they could handle many tasks in parallel, unlike traditional CPUs that focus on one or two tasks at a time.
Exactly. While CPUs excel at serial processing, one task after another, GPUs excel at parallel processing, thousands of smaller tasks simultaneously. This architecture is what made Nvidia's hardware a perfect match for certain AI computations.
To visualize this, think of a CPU as a single chef making a complex dish step by step, while a GPU is like a kitchen full of chefs, each chopping, stirring, or prepping in parallel. When training AI models, you need that kind of massive parallelism.
Historically, this parallelism made GPUs great for graphics, where you calculate millions of pixels at once. But as deep learning started taking off in the 2010s, researchers realized that GPUs could speed up neural network training dramatically.
I remember working with a retail client a few years ago who switched from CPU-based servers to GPU clusters. The difference was night and day. Training times dropped from weeks to days.
That transition was a game changer. It sparked a wave of AI innovation because hardware caught up with the computational demands of deep learning.
Exactly. And Nvidia didn't just sell GPUs. They created a whole ecosystem. They developed CUDA, a programming platform that allows developers to leverage their GPUs easily. That helped broaden AI adoption across industries.
CUDA simplified the process of writing code that runs on GPUs. Without such tools, exploiting GPU power wasn't accessible for most developers or companies.
On the practical side, this meant industries like healthcare could speed up things like medical imaging analysis, automotive companies could advance their self-driving car tech, and finance firms could improve fraud detection models.
And Nvidia doubled down on AI by developing specialized AI chips beyond their traditional GPUs. They introduced the Tensor Core, optimized specifically for tensor computations, which are fundamental in deep learning.
Tensor Cores turbocharge matrix math, the backbone of neural networks. To put it simply, they take the GPU's parallelism and tailor it for the exact math AI needs, making training and inference even faster and more efficient.
This shift from general-purpose GPUs to AI-optimized processors reflects a broader industry trend. Companies now design chips specifically for AI workloads instead of just adapting existing graphics hardware.
I've seen this firsthand with an automotive client. Nvidia's AI chips enabled their vehicle perception systems to process sensor data in real time, which is critical for safety and autonomy.
Real-time processing requires not just raw compute power, but efficiency and low latency. AI chips like those from Nvidia address these constraints effectively.
Another impressive move from Nvidia was their strategic pivot into software and cloud services. Their DGX systems package hardware and AI software together, making it easier for enterprises to deploy AI at scale.
This is crucial because powerful chips alone don't solve all problems. Enterprises need integrated solutions, hardware, software, and frameworks that work seamlessly. Nvidia's investments here lowered barriers to AI adoption.
And their NVIDIA AI Enterprise software subscription helps companies run AI workloads on any major VMware infrastructure, which is huge for businesses transitioning their legacy IT to AI-ready environments.
From a theoretical perspective, NVIDIA's story exemplifies how advances in hardware architecture can drive progress in AI capabilities, enabling more complex models and applications.
And from the business side, it's a reminder that technology companies need to evolve continuously. Nvidia's shifted from gaming graphics chipmaker to a leader in AI compute platforms. That's strategic agility.
Let's also touch on Nvidia's impact on the AI research community. Their hardware accelerated experimentation, enabling more rapid innovation in algorithms and models.
I remember working with AI researchers who said Nvidia GPUs were a lifeline during the explosion of deep learning research. Access to affordable, powerful compute resources was a huge enabler.
It's interesting how a company that started with something as visual and recreational as gaming ended up powering the backbone of AI technologies, transforming health, transport, finance, and more.
Yeah, and Nvidia's journey highlights the synergy between hardware innovation and software ecosystems. Neither alone would have propelled AI to where it is today.
To summarize, Nvidia's success with GPUs and AI chips illustrates how specialized hardware, paired with supporting software, can unlock the computational horsepower AI demands.
And for businesses, it means investing in the right infrastructure isn't optional anymore. It's foundational to compete in the AI era.
So, key takeaway for today. Advances in AI are deeply intertwined with advances in compute hardware, and Nvidia's GPUs have been central to this evolution.
For me, the takeaway is about agility. How Nvidia's pivot from gaming graphics chips to AI compute power shows the importance of adapting your technology and business strategy to the future.
Next episode, we'll dive into another tech giant, Meta. We'll explore how they leverage data and AI across social media, virtual reality, and beyond.
Should be a great one. And if you're enjoying this, please like or rate us 5 stars in your podcast app. We love hearing your feedback, so leave a comment or question. You might even hear it featured in a future episode. Until tomorrow, stay curious, stay data-driven.